Good day, my name is Alain Gonzalez, and today I will be presenting on an example that I personally worked out on the Poisson distribution. I hope you enjoy and maybe learn something new today. Don't forget to like the video and subscribe down below for more videos like these. In class, we were taught the different special discrete probability distributions. The first three are the uniform distribution, the geometric distribution, and the binomial distribution. For all these different distributions, we were taught how to find the expectation of x, which is also known as the mean of x. We were also taught to find the variance of x, the standard deviation of x, and the probability that x is this or that, etc. Now, let's talk about my example, the Poisson distribution. The Poisson distribution deals with the number of occurrences or events in a given interval of time, space, or even measurement. These events occur singly and randomly. Lambda in the Poisson distribution is considered to be the mean number of occurrences. It is always known and finite. However, the variable x is used for the number of occurrences in the given interval. Now for my example. The number of night calls to a fire station in a small town can be modeled by a Poisson distribution with mean 4.2 per night. Find the probability that on a particular night there will be 3 or more calls to the fire station. State what needs to be assumed about the calls to the fire station in order to justify a Poisson model. So let's start off by what we know. We know that x is modeled by a Poisson distribution with lambda, where p of capital X equals small x equal to e to the negative lambda power multiplied by lambda to the x over x factorial, for x equals 0, 1, 2, and can go all the way up to infinity. So from the question, we know that the mean is 4.2. So therefore, lambda equals 4.2. And so now, x is modeled by a Poisson distribution with a mean of 4.2. Also, we need to determine our random variable x. So we are going to let x equal the number of calls per night to the fire station. So now the question asks, find the probability that on a particular night there will be 3 or more calls to the fire station. So therefore, it is p open bracket x is greater than or equal to 3. P that x, the number of calls, is greater than or equal to 3. Now, how do we solve this? We can't just go about solving this because we know that the x can either be 1, 2, 3, all the way up to infinity. So therefore, we will need to find the complement. So by finding the complement, it will be 1 minus the probability that x is less than or equal to 2. Or it can be the probability that x is less than 3. So for solving this, the probability that x is greater than or equal to 3 is equal to 1 minus the probability of x equals 0 plus probability of x equal 1 plus the probability of x equal 2. And we can see by these brackets that it is 1 minus the entire probability of x is less than or equal to 2. So we know that the equation is e to the negative lambda open bracket lambda to the x over x factorial close bracket. So therefore we substitute accordingly into the equation for probability of x equals 0, the probability that x equals 1, and the probability that x equals 2. So therefore we get 1 minus open bracket e to the negative 4.2 open bracket 4.2 to the 0 power over 0 factorial plus e to the negative 4.2 open bracket 4.2 to the first power over 1 factorial plus e to the negative 4.2 open bracket 4.2 squared over 2 factorial close bracket. After substituting this into my calculator, I got the probability of x is greater than or equal to 3 equal 1 minus 0.210, which gives me that the probability that x is greater than or equal to 3 is equal to 0.790. So the probability that on a particular night there will be 3 or more calls to deforestation is 0.790. The question also asks to state what needs to be assumed about the calls to deforestation in order to justify a Poisson model. So in order to justify a Poisson model, we need to assume that the calls occur randomly and that the number of calls can be very large. As we can see, let x equal the number of calls to deforestation that can be all the way up to infinity. So these are the assumptions that we need to assume if it is a Poisson model. Also, I know the question didn't ask, but if we were to find expectation of x, this is simply the mean of x, which is the 4.2 per night. Also, if we were to find the variance of x, we know that the variance of x is equal to lambda, and we know that lambda equal to 4.2. So therefore, the variance of x is equal to the mean, which is 4.2 per night. So now I have successfully answered this question. Thank you for watching. Bye.